Hi, my name is Kenneth Wu, and this is my submission for Case Western Reserve's A.W. Smith Innovation Scholarship. My project is a computer science project. This is an application that is used to solve problem inferential statistics for AP Statistics, and the purpose was it's to make it easier to solve inferential statistics problems for AP Statistics students. There are 7 different types of inferential statistics here that can be done, and basically how it works is you just plug in the numbers for your parameters that you would get from either an experiment or something into the values. Like, let's say you wanted to find out if your sample or the sample proportion was not equal to 0.6 within like 95% confidence, and you would plug in values that your sample was given or that you were given from your experiments, and then you would get an answer. Basically, the statistics, this calculator here will tell you a conclusion based on the number that is given as well, based on the p-value and the alpha level that you give it. Now, if it was if it was 67 successes out of like 100, then obviously we don't have enough evidence to reject the null hypothesis that the original sample proportion was 60%. So everything here was coded by me in C#. It is a WPF application that uses the WPF for XAML as the front end. The logic for the front end for the main window is right here. It uses the grids so that it can refactor itself whenever you move it around or stretch it or such. It could change itself so that it doesn't like break or something. And also the back end code is also in C#. It is right here. For each type of test, there's a separate file, and every single time you press the answer button, it will instantiate a new class based on that type of test that you wanted it to do. So if you wanted to do a z-test right here, there are 4 different types of z-tests that this calculator can perform, and it would instantiate a new class of z-test and then use the logic that is put inside the z-test variables and like spit it out onto the answer screen. So the parameters are given here for the z-test, the sign of it, and then the population proportion, all the variables that you would plug in, and then it would complete all the logic in these functions down below. I wanted to learn how to like do more object-oriented like programming, so that's why I like created it in this format rather than like a more procedural way, which would make more sense for a calculator. And it is 100% functional at the moment, and if there's a value missing, then it will give you an error. For the t-test specifically, you can also put in your data in a list format if you don't have the exact like numbers and values and you're just given a list. So instead of having to calculate all that stuff yourself, you can just put it right here. Like let's say this is your let's say this is the data that you gathered in your sample, and you want to find out whether the mean is not equal, or when you want to find out whether the mean is less than 125 within 0.05 alpha level based on this data. Let's put in a few numbers just to be safe. It will run all of the logic here and give you a conclusion based on your data. So yeah, that is my submission for the Innovation Scholarship.